In order to learn how we can use matrices to solve systems of linear equations in the future, which are some of its most useful applications in the world, in business and economics especially, we must first learn how to find the determinant and an inverse of a matrix. Now, what is the determinant? A determinant is usually called that of, let's say we have a matrix defined as A, right? And the matrix is 2, 4, 5, 1. This matrix we call it as capital A, that A. Or we can sometimes use this symbol, determinant of A, right? Usually denoted as such. Now, how do we find a determinant? Pretty simple actually. Let us define 2 as A, 4 as B, 5 as C, 1 as D. Okay? We find the matrix is by taking AD minus BC. Okay, wait, let me put it this way. That A equals to AD minus BC, which in this case equals to 2 times 1 minus 4 times 5. 2 minus 20 equals negative 18. And that is your determinant. It's really simple for a 2 by 2 matrix, right? And then you have the inverse of a matrix. Okay, same. We have the matrix A. An inverse matrix is A inverse, denoted as such. And how do we find an inverse matrix? A bit more complex, but easily understandable once you get the hang of it. Equal to 1 over the determinant of A, right? Multiplied by D, negative B, negative C, A. Okay, while this may sound a bit abstract, don't worry, right? Let's use in this case, right? Let's find out for this case. 1 over determinant of A. Okay, first, before we go into that, we must understand that this holds true as long as determinant of A does not equal to 0. I mean, after all, you can't divide 1 over 0, right? So, yeah, if determinant of A is 0, then if determinant A equals 0, then undefined. Or you can say does not exist. So in this case, we found our for matrix A, we found our determinant negative 18. Then D is 1, negative B is 4, negative C is 5, negative 5, and A is just 2, right? Then using what we learned in the previous video on scalar multiplications, I suggest you checking it out. Well, our answer will be 1 over negative 1 over 18. Negative 4 divide negative 18. Let me see. Negative 4 divide negative 18. We got 2 over 9. Simplify. Negative 5 divide negative 18. We get 5 over 18. And finally, 2 over negative 18. It's just negative 1 over 9. And that is your inverse matrix of A. Quite simple actually. Let's move on into more question. Now, let us find the determinant of this matrix. Okay, determinant. Let's call it matrix P, right? Determinant of P equal to AD minus BC, which is negative 4 multiplied negative 3 minus 4 multiplied negative 5. 12 minus Negative 20 equal 12 plus 20 equal 32. Simple. Right? Let's call the matrix C. C, determinant of C, AD minus BC equal negative 2 multiplied negative 5 minus 3 multiplied by 0 equals, well, negative 10 because 3, because 3 multiplied by 0 is 0. Then finally, now we want to solve for the inverse of the matrices, right? We want to solve for the inverse. Remember, let's call the matrix D. Okay. We want to solve for the inverse. How do we solve? Okay. Inverse of D matrix D. D inverse equal to 1 over determinant of D, capital D, D negative B, negative C, A. Right? First, we find out what is the determinant of D. 10 multiplied by 0 minus negative 1 multiplied by 0. Then D 0, negative B 1, negative C 0, negative 0 0, A is 10. Okay, you might have noticed something here, right? Our determinant of D, well, is 0. And therefore, D inverse does not exist. Now, let's define this. The second question, the matrix as E. We want to find E inverse, right? 1 over determinant of E multiplied by D negative B negative C A. 1 over determinant of E. Okay, I suppose that it's not going to be 0 now. Let me check. Okay, negative 3 AD minus BC minus negative 3 negative 4. D negative 3, negative B is 3, negative C is 4, A is negative 3. Nine minus negative 3, negative 4, yeah, negative 3. So it's solvable actually. Negative 3, 3, 4, negative 3. Okay, scalar multiplications is always pretty simple. Negative 3 divide negative 3, 1. 3 divide negative 3, negative 1. 4 over negative 3. Well, I suppose negative 4 over 3. Negative 3 over negative 3, 1. And that is your final answer. That is your E inverse. And that's it.